Hi my friends. The other day my friend Javier from Bilbao, Spain sent me this message. He wants to help him to make a model for this washer. As you can see, it is not regular or geometric, but it has dimensions: 48 millimeters the outer diameter, 34 millimeters is the inner diameter, the thickness of the part is 5 millimeters, and the height is 8 plus 5 millimeters. He saw my tutorial 233 where I presented you 3D equations for modeling parts. I advise you to take a look at this tutorial, which can be found very easily by using the general index table, Excel table, which is presented at the beginning of each of my tutorials. The final model is this one, and you see this has a nice shape because we use mathematics, my friends, with no empirical solutions as we see through other tutorials. If you take a look from above, you see that it is perfectly circular, internal or external, and it has some curved faces up and down. Of course, to make this model, I've created a drawing. This is the drawing. You see dimensions and the isometric view for the part. Okay, that's the problem. Let's try to create the model itself. I start by creating a cylindrical surface in the middle of this internal and external circles. I don't want to forget to draw your attention to the fact that this washer has 3 identical humps, so it will be enough to create only one, this one for example, and then multiply it in a circular pattern multiplied by 3, of course. Let's go. New standard millimeters IPT, sketch on this plane. I rotate it to be with the x-axis to the right. I create a center point arc in the center point of the system with a radius of 48 plus 34, 4, divided by 2, and divided by 2 because it's a radius. Tab, starting from vertical, from 90 degrees to 120. Finish sketch, extrude. We extrude an entity and this means that we obtain a surface, not a closed contour, to obtain a solid. I select this solution and the dimension is 13, as you can see. And now we go to the 3D sketch and we select equation curve. As you can see, we have 3 lines for 3 equations, parametrical equations. I write them one by one and you must be very careful. 48 plus 34 divided by 4 and multiplied with the sinus of t. You see, t is the parameter for all the 3 equations. Next is y. You see, y is another dimension on vertical, so that we write here 4 times of cosinus of 3 multiplied by t. I place here the maximum value of t to have a graph there. And here is the same equation like the first one, but with cosinus, not sinus. 48 plus 34 divided by 4 and multiplied by cosinus of 3 times t. No, cosinus of t. This is with 3 times. Okay, what is this? Well, this is the curve, sinusoidal curve of 1/3 of the whole part. In the middle of the 2 internal and external cylindrical faces of the part. Okay, now I create a plane. I get out of 3D sketch and I create a plane based on this point, end point of the curve, and the curve as a base. This plane is perpendicular on the tangent in this point of the 3D curve. Yes? Good. And now what? Now, since this is, as I said, the mid-plane of this section, I use the center of the rectangle. This rectangle has 5 millimeters one side and 34 plus 48 divided by 48 minus 34 divided by 2 because it's this and this, so that we have to divide by 2, which is 7, my friends. 48 minus 34 divided by 2 is 7, but I always write the dimensions in the drawing. We know that this is 7, but when you try to make them by heart, you can fail. Okay, a rectangle, yes, where? In this plane. I create a sketch. Rectangle centered in the center in this point, but I cannot select this point. Yes? Why? You know why. Escape, because I have to project. I know that this point is in the plane, but I have to project it in the plane. Now I can select it as the center of the rectangle. I place here 5, tab, and then 48 minus 34 divided by 2. And we have this rectangle. You can be tempted to use the rectangle and the curve to create the part, but you will see that this is a wrong decision. Let's try. Finish sketch, sweep. I select solid, not hollow entity, this rectangle, and then I select the curve, but this solution. Select the curve for the sweep, and we obtain something very interesting and which seems to be okay. Good. Let's see how okay is this. I hide this this cylindrical extrusion, and I hide also this, no problem. And now I apply circular pattern for this feature, all the part, all the body, and the axis of Y, origin and Y, not 6, which is by default, but 3. Okay. Oh, the part is ready. No, my friends, it is not ready at all. If we take a look from above, we see something which is not what we want. What is this? What is this? If we look from the side, we see that this line is horizontal, okay, but at the bottom it is not horizontal. Look here. Yes, this is horizontal and this is not horizontal. Why? Because we used too few entities. Let's try other solutions. I eliminate circular pattern and also the sweep, but keeping the consumed entities. Delete, keep them, OK. Now we'll create 4 new 3D curves like this one, but starting from each corner of the rectangle. To do this, we'll create 4 3D sketches with equations, one for each corner. This is parametric system of 3 equations for the mid cylinder, and the other 4 will be used right now. Here you see that all the equations are Cartesian, and the limits are 0 to 120 as it was here. Let's do this. We start 3D sketch. We don't use points or entities from this image, but only equations. We are sure that they start from the very point of the rectangle, because this is mathematics. Equation curve. I copy and paste each equation from my own table. Copy and paste. Now I write here 20 to have 120, and the last equation is this one. What we see here? We see that the first point is this one, which is upper than the center with half of 5, and this happens on the y-axis, so that we use the same terms but adding 5 divided by 2. This is not 48 plus 34 divided by 4, but exactly 48 divided by 2. This is the distance between these two. This is on the circle of 48, and this is on the circle of 34. Good. Okay. You see, this is the first 3D curve. We do the same for all the other. Finish sketch. Start a 3D sketch, a new one. Equation curve. Copy the first equation, paste second equation, paste, and the third, paste here. 120 is the T max. And we have the second 3D sketch. Finish this sketch. And another one is starting with equation curve, copy, paste, copy, paste, and the last is this one, 120, the angle. Finish sketch, new 3D sketch, equation curve, and copy, paste first equation, second equation, third equation, 120, and OK. Don't forget to apply OK. Finish sketch, start a new 3D sketch, the last one, copying the last set of expressions, equations, paste, copy, paste, copy, paste, 120, the last one is this one, OK. Now finish sketch, and you see we have 5 3D sketches. One was this one and the other are this all. I show you that they are totally not dependent of everything. You can place them everywhere. Yes, they have no other connection with the model because they are created as equations. Good. Now we have more data to create our faces. We have to create faces for each side of this tunnel. How can I call it? First thing is to hide the mid curve because we don't need it anymore. Good. How can we do this? We use the sweep tool by using each side of the rectangle and 1 or 2 curves, but I cannot use directly a side of the rectangle, so that we make visible this plane. We create a new sketch, 2D sketch, to project one side, for instance this one, finish sketch, then I hide the previous sketch, I only take its visibility to select this segment, not any other one. Then I apply sweep for this line as profile, and I'm the inventor waits for me, because you see this underline, blue underline, waits for me for selecting a curve or an edge. I selected this, but I don't have the preview, so that I try the other solutions, and I see that I can select a rail. Oh, let me select a rail. Which rail? This one. Now I don't have what I need. I don't have OK here. Select profile. This is already selected. Once again. Sweep, select this one. I try this other solutions and this, and I don't have. Oh, I have to select the surface instead of bodies. Yes, this is my fault. You see, all over this two curves, 3D curves, define the surface. Okay. The same for the other. I make visible the rectangle. I create a new sketch. I project this bottom line. I finish sketch. I hide the base rectangle, and now I have this profile. Sweep. Now I am sure that surface is selected here, not body, not solid. I select this and one of its sides, and I try other variants to see if I respect what I need. Yes, I do respect. No, I don't. You see, here is the border, and we are here. So that I go here and I select the rail. The rail is this one. Now I'm sure that it is okay. You see, the border is respected. Okay. Once again, we have 4 such surfaces to create. 4. Sweep. Oh, but I forgot the profile. I make visible this. I project this geometry to have a profile. Then I hide the sketch, the base sketch, and I have the profile, and these are either the directory either or rail. Sweep. Profile. I'm ready to place a curve here. Then another curve is this one, and I select this rail so that I have a good and correct contact with borders. Okay. make visible this, create a sketch, project geometry, which one? This one, finish sketch, and now if I don't hide this sketch, look what happens. Sweep, I try to select the upper line, this one. It seems to be selected, but it was selected all the rectangle, you see? So that I renounce, I hide the sketch, and now I'm sure that I'll select this line, sweep, profile, rail, and the other rail. Okay, then we apply a lid, a plane, by using this point and this 3D curve. You see, we have to place lids to the ends. Then sculpt. 1, 2, 3, 4, 5, and this was selected already. Okay, and we have a third of the whole object. Now we use circular pattern for all this object about an axis. Which axis? Y axis, with 3 instances. Okay, and this is the object. Very good, very nice. Let's see from the side, from the other side, from up, and everything seems to be okay. What about other features? We have 2 fillets, 4 fillets of 0.2. 0.2 millimeters. 1, 2, 3, 4. Okay. Good. View, visual style, shaded, and carbon steel, semi-polished, and this is the object. Let's see what about eye properties. Eye properties. Are physical update and close, double click, blank, somehow near this model. You can try for yourself to apply each step here to see what is the real volume. Okay, and that's all for today. Thanks for watching. Bye bye.